Okay, so, hi everybody. Hi, there is, sit down. Hi everybody. So, I'm Talya. I've been at Wix for almost 6 years. Done many things in the core server areas. Previously have been known as Miss Petri, but lately, for the last year, I've been in the new CI group. Yay! Woo! Yay. And I'm here to talk to you today about the project I spent most of the last year trying to build. So, quick show of hands. Who here has been lucky enough to use wazel? Who here feels lucky? Yes, okay. So I'm going to be talking about this. Many buzzwords here, okay? Bazel, Docker, Mac. This is the story of my journey to try and build a development environment for all of our Mac users. It was called wazel because Wix bazel, okay? And spoiler, okay, right at the beginning. The journey does not end where we wanted it to end. We did not make it. This is an actual screenshot that my team leader showed to all of the server guild a few weeks ago when we were talking about what we've achieved and what we've done. And it was a really long and fun and interesting journey. Hopefully by the end of this lecture you will know many fun technical details about Bazel, about Docker for Mac, but also hear the general story of what it was like to have a really big and interesting research project. And hopefully it will help you next time that you're doing some kind of research task. So, day one, okay? The journey starts at May 2018. This is almost exactly 1 year ago. Wix was in the middle of doing like this big move to Maven, okay? To leave Maven and to move to Bazel, okay? To change all of our build system. And this was an exciting time, okay? And before I explain to you the reason why I'm here and why we had to build something for Wix, let me explain a few basic things about Bazel, okay? Some of you may know this, some of you may not. I will explain everything that is relevant. So, in Bazel, which is a build system, okay, the basic unit, the basic action is something which is sandboxed. And sandbox means some kind of isolation from the system. And it basically means that we treat every piece of it can be a compilation or running a test, okay? And every such action is sandboxed from its environment. It means that you get a dedicated, isolated piece of the network if you need it, and a dedicated, isolated piece of the file system if you need it. And then everything can be viewed as like a stateless, pure function, okay? You have inputs A, B, C, and D, and the calculation is always the same. Just to make this concrete, the examples could be the actual code that you change. Okay, this is like the most easy thing to understand. It could also be any external dependencies you have from Maven, like, I don't know, Yoda version 4 or something. It could be the operating system that you're working in, because this also affects computation and things that happen. And it could be any native tool you're using, like, I don't know, the C++ compiler that you need for protobuf generation, for example. Okay, so given all of these things and the fact that we're isolated from the environment, then the result of the function will always be the same, okay? This is the same way we talk about functions, okay? It's stateless, and if it's stateless, it means that the result is always the same. So just to make sure we understand the implications of this. Isolation, it's a big word, okay? We can also say hermetic sometimes. This is like the main benefit that Bazel gives us over Maven, okay? So if things are reproducible, if the function always gives us the same results, it is reproducible. And what can we actually gain by things being reproducible? First of all, results that have previously been calculated can be reused. They can be cached, okay? So if, for example, you have a test that depends on code, and you change the test, but you don't change the actual code, then you only need to rerun the test. You don't need to compile the code again, okay? Now, if you think about this, like when you have many modules and a lot of code, then this can be a very, very significant improvement for speed, okay? Because you only need to build and test the things that have been changed by the one change you made. You don't need to run all of the Maven modules that depend on your chain. The fact that things can be incrementally calculated and cached also means that you can share the results, okay? So if, for example, something has been built on my machine, then maybe someone from my team can use that result. maybe it's already been built on CI, and I can already use that result. So if I'm compiling something locally that has already been compiled with the exact same code on CI, we can use that result. It does not have to be locally calculated, okay? And another main benefit is that everything can be run in parallel, okay? Because if I have two tests that don't depend on each other, there's no reason for them not to be run together because they're isolated, and no one cares about the actual network outside because it's just this nice box that pretends to live on its own. And this leads us to the famous bazel branding that we all know about, okay? This is a build system that is fast and correct, okay? And it says choose two because usually you end up having to trade off one for the other. So we were moving Wix to use bazel, and we wanted all of our developers to also enjoy this thing. Now, one last thing I want to make sure that we understand about the implications of this isolation is the fact that things are reproducible and doesn't matter where you want them, okay? So if things are on my machine or on CI, they are the same thing. And this means that all of the results that we run on CI, so like I keep saying CI, let's remember CI is continuous integration, okay? Everything that you commit and push is built. And once CI has built this cloud of actions and everything, if you now come to your computer, okay, let's say you haven't been at work for 2 weeks, you pull master, and you want to change one line of code. So instead of building all of the code in this chain that you're looking at, you can actually utilize all of the cache hits of the things that have previously been calculated on CI and only locally calculate like these 2 things, for example, that you've changed. This is huge, okay? Like think about how things work in Maven. And now imagine, well, you don't need to imagine because you're already using this, right? Like it's a huge, huge speed gain. So bazel is awesome, we all agree, but why am I talking about this? So let's remember, now it's already 270 developers, server developers, and the vast majority of us have Macs, okay? We have a few Linux users. I think I can use like 2 hands to count them, but the vast majority are using Macs. And bazel behaves very differently on Mac. We'll talk about this soon. But the idea was that we wanted everyone to be able to use it. So what's different with bazel on Mac? Why is this even an issue? So you remember these inputs that I talked about, like the code and the tools you depend on and the operating system. That's one of the things. CI runs on Linux, obviously, and Mac is not Linux. I know some of you may be thinking, why do I care? This is JVM, right? Like the whole point of JVM is it's compatible, it's cross-platform, we're not supposed to care about this thing. So the explanation here is there are 2. One is that bazel actually overcomplicated things. But the other thing is that even though we have JVM, we also have other native things, for example, Proto, which means that we do depend on the native C++ compiler and stuff like that. So basically what this means is we can't share locally on our Macs the cache that has been built on CI. Not a good thing, okay? This is like bad for speed. The second biggest thing, which is the whole isolation, actually does not really exist properly on Macs, okay? So if we look, for example, on Linux, isolation is the basic capability of taking, dedicated slices of the network, of the file system, and pretending like this is the only thing that exists. Now, on Linux, these things are implemented via 2 very basic building blocks that the kernel gives us, okay? They're called user namespaces and C groups. User namespaces is a way to group processes together and say these are together as a group, and they can talk to each other network-wise and only to each other. C groups is another mechanism that allows you to split the CPU so that the process thinks it only has 1 CPU, even though it has maybe, 8 cores in the machine. And this is actually the basics of how Docker is implemented, okay? So Docker on Linux just uses these 2 Linux kernel features to build sandboxes. Mac OS, previously known as OS X, does not have this thing. So as most of you probably know, we use static ports in almost all of the code in Wix, right? Like 9901, everyone here has seen this port. And the fact that we don't have isolation on Mac means we can't run tests in parallel, right? Because if two tests are going to use 9901 port at the same time, they're going to collide. Nothing can be run in parallel. So you may be thinking, okay, so let's stop doing that, because we've had talks in the past about randomizing ports. It can make more sense regardless of bazel. And we actually thought about this. So I tried seeing how to go about this. And this was the first, let's say, slap in the face I got from the OS6 region. So this is a screenshot of an issue I opened back in May. And I opened it to Bazel team, okay? Because I tried using the sandbox of Bazel, and I tried running it on Mac, and I tried binding to localhost, which sounds like a very trivial and normal thing to do, and it wouldn't work. And this reply here is from the guy in Bazel who is like the sandbox guru there. And basically he said to me, yeah, I know this kind of sucks. This is what macOS gives us. And this is an actual screenshot from the official open source code of Google of their gRPC server. I will read the text to you, okay? It says, for reasons only Apple knows, you cannot bind to IPv4 localhost when you're in a sandbox, but IPv6 is okay, let's try this. If you remember the lecture from the morning, I think most of you were there, not all systems in the world have actually moved to support IPv6, okay? So I don't know why Apple decided to do this thing. Obviously, we're not the only people annoyed by this. And this was when I realized we had some really, big gaps that could not actually be solved on Mac. So just to make sure that we're aligned at this point on the problem and on the gaps. No CI cache sharing. Who here thinks that this affects correctness? That's right. Who thinks it affects speed? Yay, okay. It affects speed. Good. No parallel tests. Does this affect speed? Yes. Thank you. What about no network isolation at all? Remember, I just showed you that we could not isolate things and access localhost, okay? This means we cannot run any test with isolation, even without discussing parallelism. Is this an issue with speed? Maybe, okay, so it's a complicated one. Maybe it's about speed. It doesn't really matter because we couldn't run things in parallel to begin with. So this is actually a correctness issue, because it means we take away that nice sandbox, which gives us hermeticity and statelessness and reproducibility, and we say, okay, so we won't sandbox it, and now maybe we can access external network, maybe we don't, who knows, maybe the test will pass now and fail later. And this is really bad, because we wanted Bazel to be fast and correct, right? And we've just taken away both of these benefits. So this was the point when I realized that I had a really big task to do, okay? It was not just about verifying things anymore, it was about building something else. And what we wanted to actually do was to get to the point where all 270 developers could use Bazel on Mac and get the full benefits and be happy and feel good about this. So I set off to my journey, and at this point, most of you have probably been guessing, or you already know from before, that the answer would appear to be Docker, right? Because if we want everything to behave like Linux, and we want things to be contained, and we want them to be identical to CI, then it's pretty clear, let's build a cute Docker image, let's put Bazel inside of it, and everything will be identical to CI, and that's it. So just to make sure that, we understand the picture. So what we have here is your Mac, okay? We have the IDE where you write your code, probably, most of us at least. And we have Docker for Mac installed inside it, okay? Now, the reason we have this cute penguin there is because Docker for Mac actually brings its own Linux VM, precisely because of what I described before. If we want to be able to isolate things and to have containers, then we need to use something like user groups, something like user namespaces and C groups to get this isolation. So Docker on Macs and actually on Windows as well comes built in with its own VM, which is kind of hidden and managed and more lightweight, but it has Linux inside. And then we have this really main single and main container which runs Bazel inside. And the idea is that, we're on the Mac, happily typing in IntelliJ the code. Somehow the container inside needs to be able to read the source code. Then Bazel runs, generates outputs, runs the tests, builds your binaries, whatever. And then we want the outputs to be accessible back in the IDE if we need them, okay? And just to make sure we're clear about why the IDE needs to see the outputs. So the outputs could be test logs, which of course we want to see, and hopefully in real time. It could also be the binaries that we build, and it could also be, for example, all of the external Maven dependencies we depend on. Okay, so if we build code and that code needs to bring Yoda time, we probably want to be able to see this jar and its source code because, we want to debug stuff and see what's going on inside, stuff like that. So I built this thing on my machine, and it was very, very clear that it was not going to work well. So the source code, when I mounted the source code and I tried benchmarking and running some kind of bazel build, it was slow. It was like 160% the time of doing it without mounting the source code. Maybe we could live with that. But the moment I tried mounting the outputs, I'm talking about bind mounts, okay? Like when you define a volume in Docker in the regular native way. So once I tried binding the outputs so that they would be available back on the Mac after the build, it was just impossible. I didn't even complete the benchmarking. I think it was like, the native time was, I think, 20 minutes. When I tried mounting the outputs, I stopped after an hour and a half because I just didn't care anymore. Okay, like it was maybe halfway through, and I realized this was not going to work out. So I started researching stuff, started reading all sorts of things, and I realized kind of quickly that this outputs issue was actually notoriously known. So Docker for Mac, it's been known for a very long time that the performance of the file system over mounted volumes sucks, okay? And their documentation kind of states that, and they also spent quite a lot of effort on improving this. And they've documented all sorts of improvements, which were supposed to be like relevant exactly from High Sierra, which was when we were actually doing this whole thing. And they had different flags, which were supposed to improve the performance of all sorts of scenarios. And it sounded kind of promising, and I tried using these flags, and they didn't change anything. And then I read more and more stuff, and I found the actual GitHub issue, where thousands of people have watched it, and everyone is super annoyed there. And the bottom line is that even though they've documented this new flag, they have not implemented it. So they've documented what they want the spec to be, but it's not implemented, and the documentation does not say so. You have to find your way through the internet to it. Super annoying. So one really well-known open source project is called Docker Sync, and it was built precisely to try and avoid this issue. The description of this project says, run your application at full speed while syncing your code for development. Okay, it sounds good, it sounds like it solves our issue. I tried using it. I spent hours looking at the numbers, waiting for things to finish, and then I realized it didn't really work for our case. So this project is actually, it's a really good one. I have some hidden links later on to the architecture and loads of performance testing that the guy has done. Really good stuff. But it was mainly built to allow you to deploy the web application that you're working on locally to make sure that it works well when it's deployed on Linux. It wasn't meant for this output scenario where you are writing many, many things, okay? So this is like a write-heavy scenario. So this was not a good thing. We also discussed, we thought about other solutions, maybe building a whole VM. I think after asking quite a few people, it was very clear this was not going to be a very liked option. Starting up a VM takes a lot of time. It's like, you can get to 3 or 4 gigas of just the ISO image. Doing restart takes minutes. It's not fun. And we also thought about other directions. They were based on theoretical bazel features. None of them were baked enough when we tried this. And we realized that, okay, Docker for Mac is probably the direction. The Docker Sync project is a good beginning. And I was going to try and build something based on this, which would work for our very specific use case, not for everything, but for us. And this was when I decided to try out and build the first solution which would actually bypass all of this issue with the file system. So since we said that our issue was this output-heavy scenario, I tried to replace it with a local web server, okay? Now, NFS is it's a protocol for transferring files over the network. Maybe some of you have seen it in the past, I don't know, my workplaces have always had a shared drive with all of the pictures from the latest company fun day, where you could access stuff and download them. And it's a protocol that's meant to transfer files, okay? So I just put it locally inside of my machine. It's all on localhost, so all of the network is very, very quick. And this was a way to bypass the actual hypervisor and the way that it actually dealt with files on the disk. And it seemed to work quite well, okay? At this point, we had 2 repositories that were working with Bazel already. One of them was Wix Framework, which was, one of the frameworks that suffered the most from Maven, and we knew it took a long time. So we felt good about letting these people try and use this. And it seemed to work quite well. The few users we had were happy with it, and then we decided we had a name. This project was going to be called wazel, and I was kind of happy, excited, and I set out to implement this thing and make it into a product. So, this picture looks kind of simple, but if you break down what actually needs to be done in order to make this a product that, all of our developers can use, then it's quite a few things, okay? So I wrote a Python installer that would download stuff. It also had to check the version of your Mac OS and the version of Docker for Mac, and things were moving and breaking all the time, but, it's Python, it's okay. We had to mount the SSH keys so that we could actually access the code from inside. We had to bring up an NFS server locally and expose it on the correct ports and paths and everything. And we also had to write a small script that would wrap bazel inside, okay? Because the story here is that you want to just type, I don't know, bazel test something, and this thing has to seamlessly go inside the Docker and run bazel inside of it and let you know when it's done and so on. So I had a lot of fun with the script. One important thing to remember about Bash, don't. Just don't. Even if it's one line, don't do it. It will become more than one line, you will regret it. I also had to learn more than I wanted to about IntelliJ, because the plugin of Bazel for IntelliJ needs to know where stuff exists, and it writes all sorts of files that it needs to write back, and signal handling in Bash was also lots of fun. We had to propagate the signals inside of the container, and Bazel does some weird stuff of its own, so things were colliding, but this was cool. It was a good time. I was learning lots of stuff I was not very familiar with before, and it seemed to be going quite well. Until, so I was really happy, eating pizza, partying, all of this thing, until we started onboarding more people, okay? So like I said before, we had 2 repositories, and one of them was Wix Framework, and we thought this was a very good thing because it was a big and heavy repository. But then more and more repositories finally completed their migration to Bazel, and they could start using this new tool. And then this is an actual image from Slack, okay? So people were receiving many errors that said device or resource is busy, and other errors like slow file read. And this was an error that I had seen once before on this guy's machine, but only once. And suddenly it started pouring in. People were, sending, when I searched for this in Slack, because I wanted the picture, I had dozens to choose from, okay? It wasn't fun. And then we realized that the scenarios that we had tested before with the other repos were only examples, and they did not cover everything that could be tested. So don't try to read this, okay? I know it's a lot of data. The point here is to show that I spent a good amount of time benchmarking stuff with various options. And the bottom line of this was, at least in the scenario that I tested here, mounting the outputs via this NFS thing actually took twice as much as running things without mounting the outputs. The data I've put below is actually just to show that the number of things I had to consider while benchmarking was the version of Docker for Mac, the version of OS X, how many cores I had given the Docker. Okay, it's a matter of how much resources I allocated to it. So as opposed to the lecture that we just heard before, it was not so easy to decide what we're benchmarking, okay? It wasn't let's reach 1,000 RPM and measure the throughput. It was more let's try and simulate something that looks like a developer who's actually doing their day-to-day job. Anyways, at this point, it was kind of clear that this solution was not going to be good. And I was pretty, upset because it spent all of this time building Bash and Python scripts and stuff like this. And then I moved on to the second option. So this seems kind of similar, but notice two differences. One is that instead of NFS, it says SMB. SMB is another file transfer protocol. And also, this local server has moved to be inside of the Docker container, okay? Before it was outside in the Mac, now it's inside of the container. I believe that this would be better because Bazel is the one that's actually doing most of the work, right? Like we have this container, it's generating loads and loads of outputs, and it's writing them. And writing to the server that's sitting inside of the Linux VM is actually native, okay? It's native speed. So as far as Bazel is concerned, there's no Mac. There's nothing weird about what's going on. And this also seemed to be working well until, this is another set of Slack messages, until in certain scenarios, people started receiving errors about weird inconsistent file system state, okay? So what this says here is it says, IntelliJ info.txt is a directory. What? Like, this is a file name. Why is someone thinking it's a directory? What's going on here? So at this point, we started writing like scripts that tried to simulate the way SMB was behaving. And we managed quite quickly to get it into a state where if we wrote enough files and read them back quickly enough, we got this error, which is very weird because SMB is meant to be a protocol for transferring files, right? Like, what is this about? And the actual symptom that most of the people felt was not this error, because this error was kind of hidden. But what it caused was people to see the now infamous, what we call them, the red squiggles in IntelliJ, okay? So like someone would have an import of a file, and the dependency for Maven would appear to be there. This is a screenshot of an actual jar that exists, but if you look, it has no sources in it, or so it appears. So at this point, if I went into the Docker container of Bazel, and I looked at the jar, it was fine. The sources were there, everything looked normal, but the Mac, the way it could view it from the outside via SMB, seemed to be broken up, because it thought it was a directory instead of a file, or vice versa. Super weird stuff. At this point, I was getting loads of these messages, okay? And it was pretty clear that using some kind of network-based file transfer thing was not going to be the solution. So we tried one last shot, which was using rsync, which is actually a protocol for keeping files in sync, but what it does is it duplicates the files, okay? So what we had was Bazel writing many, many output files inside, and then rsync copying it back to Mac. So everything here is native, okay? Bazel is happily running along inside of the container. It's writing to a native file system, as far as it's concerned. And then the IDE, on the other hand, is also reading things natively from the file system. So everything sounds great here, right? Now, rsync is a very, very mature protocol, okay? It works very well. And this was actually fully correct, okay? There were no more weird errors. Everyone knew what was happening where, but the more outputs you have, and the more hierarchy you have inside of this directory of the outputs, the longer it takes rsync to understand what it should be syncing. So even if you have no changes at all, it could take it like tens of seconds just to traverse the whole directory and figure out that nothing had to be synced. So this obviously was not going to be the solution that would make everyone happy. And this was the point where our head of development decided to send an email, basically to all of the server guilds, saying, end of life, okay? Wazel is end of life. You can see the date here. It says February 14th. This is like, I remind you, the journey started at May 2018. This is February 2019. And my favorite sentence here is, the only way a company can encourage this is if everyone knows it's also okay to fail. Okay, so like this project did not succeed. And before I tell you my takeaways from this thing, let me just explain what we do have now, because as you know, we have moved to Bazel and everyone is using it and everything is okay, like nothing happened. So what do we have? Going back to the original gaps which made me try to build the solution. So we have, and we still don't have, the ability to share things from the cache of everything that is run on CI. What we do have is we've built a solution of shared developer cache, okay? So when you are running Bazel on your machine, it's actually sometimes uploading the results to a shared cache of everyone who's running on Mac, and then your teammate can actually utilize this. So I've marked this with a V because we've solved the speed issue. I can't say I'm too happy about this because like the results you have from this cache are not identical to the results you have from the cache on CI, which can sometimes not be so much fun. For example, if you're dealing with something that's network related. But it solves the speed thing, and for most cases, it's probably good enough. The second gap was no parallel tests. So we still don't have parallel tests on Mac with Bazel. That is impossible to do. But because we've moved to using Bazel in CI, and because we've also moved from TeamCity to GCB, yay, we're all happy. So actually what we have now is a build system where we can build pull requests as much as we want. It's really fast. Like no one has to wait anymore for a queue of 2,000 jobs to disappear. It just runs on GCB. So you cannot run parallel tests, but it's not so bad because you can get really quick feedback like from your CI system. Also, it means you have to be plugged into the electricity much less, which is fun. And the last thing was the fact that we don't have any isolation for network tests, or, we don't have isolation at all, de facto. So this is still the case, okay? This still harms correctness. It means that locally you cannot run in the same way as you run in CI, and you can actually make the mistake of writing a test that accesses external network, and then only CI will suddenly fail, and you won't know why. On the other hand, most tests are probably, they either don't talk to the network, or they're copied from other similar tests, so this doesn't happen like all that often. Okay, so going back to this email that was sent to everyone, and going back to a few interesting conversations I've had since then, okay? I've had people walk up to me and ask me, so, like, what was that like? How are you feeling? Are you okay? What's going on? And it actually gave me the opportunity to have some really interesting conversations with people about, like, the stress of the things we sometimes do. And actually, first, let me say, my first initial feeling after this email was relief, okay? Because at this point, those Slack messages I showed you, they were like, I don't know, coming in like maybe a dozen a day. It was not fun, okay? Like it was pretty clear to me that I've built something that was causing people pain, sometimes gain, but mostly pain. So I was relieved, but if I zoom in into this period of time where like most of the time was spent, this is what it felt like more or less, okay? So there were many small ups and downs, there were many small wins, especially with all the Python and Bash stuff. I was feeling like really good about myself there. And then there were all of the failures, okay, of suddenly, like I go into work one day and then Slack is full with 5 messages of people complaining about the same stuff, and I'm like, oh no, this did not work out. And it kind of felt like climbing up this big mountain that no one had ever climbed before, and I kept believing I was going to reach the top. And then just before the top, I realized, no one could get there. So it wasn't so much fun at this point. Luckily for me, I had supportive management, and even when I was feeling a bit down, I could go and talk to people, and they would tell me it's okay and it's part of the game. And we knew this was a research thing, and we knew that we might not succeed, but we also knew that we really wanted to give it our best shot and try and see if we could give this, like ideal story to people. So, what did I learn from this? 1, we should all be very happy about our day-to-day job, okay? Deploying web services is fun. You click one button, it's all deployed to servers. You know what the servers are, you know what the operating system is. You have monitoring. You can tell within minutes or even less if things are okay. It's not like people saying it doesn't work on my machine, and then I discover that, I don't know, like Docker for Mac 18.04 broke something that Mac OS depends on. So that's fun, okay? Like I want to go back to my day-to-day job. That's nice. The second thing is that, again, being used to deploying web services, it's like being very used to the D in the R&D, to the development part, okay? It feels very good. You get feedback all the time. I write a feature, I deploy it, people use it, I know that I did a good job. The research is is different, okay? And I had to realize first that I was out of my comfort zone, and I had to accept that this was okay. I got help from several people in the guild, which did an awesome job, and they helped me a lot. And recognizing when this was like completely out of my expertise and when I should go and ask for help was a very good thing. It saved us like weeks of work at some point. And another good thing I can say that I did was, well, I felt I was over-documenting, okay? Like the amount of material that I've written in shared Google Docs and on my computer in notes and stuff is unbelievable. A lot of it came in handy like weeks later when I wasn't even expecting it. All sorts of measurements and stuff and links to different issues that other people have encountered, like stuff that I didn't even know why I was writing it down. It came in handy. So do that. Okay, another important lesson, this kind of sounds obvious, I think, okay? Like, you know, test as close to the real situation that you need to, as fast as you can. One of the things that were kind of, you know, annoying to find out was when more people from more projects started using this thing. And I think at this point we also realized that the IDE was a very big player in this part because it has to read all of the files and it does it in a very specific way. And when I was benchmarking, I was mostly using the command line, okay? Because it was easier and you know, it was easier to reason about. But whenever you can, try and capture like the actual scenario that you're going to be given to people. This is also an important lesson. So know when to quit. Sometimes good enough is better than perfect. So perfect in this case is the story that I wanted to give to you, right? Like, let's all run on our Macs. Let's pretend that it's Linux. Let's get all of the benefits. We want everything to be ideal. This was not the case, but if I go back to the explanation about what we do have, okay, so I have my issues with it. Some things here actually make me really sad, but I won't go on about this now. But it's okay, like people are developing things on CI are super quick, pull requests are giving people feedback. It's okay, it's good enough. Maybe at some point we will get to perfect, maybe things will change, I don't know. But for now, it's what we have and it is okay. And the last lesson, I think, which at some points I needed other people to remind me, which is why I'm saying this to you now, is to have fun, okay? Like you're taking on a big research project, you're going to learn many things. You may fail, but it's part of the game, okay? Like at the end of the day, we're here because it's really fun to write weird scripts that solve solutions and suddenly change stuff. That's it.